Okay, good morning, my dear students. Good morning. Welcome to the Unacademy English channel, my dear students. Welcome to the Unacademy English channel. Okay, myself is Dr. B.N. Rao, having 17 years of the pure academic experience, my dear students. Okay, out of this experience, from the last 10 years, I was supposed to be teaching the various subjects like communication systems, okay, core instrumentation, electronic devices, and VLSI design in the departments of electronics and communication engineering and instrumentation engineering for the competitive level examinations like GATE and engineering services, my dear students. Nearly I dealt 200 plus batches across all the locations of the country, my dear students. Okay, not only I dealt 200 plus batches among these particular supply, that is specializations, my dear students, I delivered nearly webinars and seminars on the GATE and engineering services awareness, how to crack the public sector jobs in the state government and central government, and okay, what are the various types of technical courses that are offering in the IITs and NITs, my dear students, have delivered in the form of the webinars and seminars, my dear students. Okay, recently, I received the PhD in the Department of ECE, my dear students, from low power VLSI design. Okay, so low power VLSI design, my dear students. Okay, and these are all the important things. Just I would like to bring it to your notice as far as the my profile is concerned, my dear students. Okay, similarly, when comes to subscriptional parameters, two important subscriptions are there. One is iconic subscription and second one is plus subscription. Okay, if you are going to take the iconic subscription, this is the one of the most dedicated subscription, my dear students. If you are going to take this particular subscription, okay, you have a personal course that is assigned for each and every subject regarding the GATE and engineering services level competitive level examinations. Okay, and this personal coach will depict you. He is the structured detailed study planner. Okay, from that is starting from the basics to the till end, my dear friends, in a detailed manner, followed by the that is gate problems, model problems, and formulas, all those things, my dear friends. Okay, and my dear friends, expert guidelines also you are going to receive over here. Okay, from the topmost educators of the academy, my dear friends. Okay, not only the GATE course but also the engineering services also that is present here, my dear students, over here. Okay, engineering services level, mains level guidance also you are going to get over here, my dear students. Okay, this is about this iconic subscription. Okay, when you are going to take this particular subscription, my dear students, you are going to get out with a good job in the central government or state government, or getting a good rank, good seat in the IITs or NITs, my dear students, as far as MTech or PhD is concerned. Okay, and iconic subscription is the most dedicated subscription, my dear students. Okay, similarly, when comes into the plus subscription, when you are going to take this particular subscription, my dear students, you can access the live classes from the topmost educators of the academy. Okay, similarly, you can practice unlimited test series with respect to the structured timetable, my dear students, that is present over here. That is present over here, my dear students. Okay, so as a plus educator, I'm going to give this much importance to this particular plus subscription also, my dear students. Okay, similarly, when comes into the fee structures for plus subscription for 12 months, 27,225. For same plus subscription for 18 months, 34,650. And for 24 months, for the same plus subscription, 39,600, my dear students. Okay, you can use the code, okay, and okay, take the subscription for this plus. Okay, similarly, when comes into the iconic subscription fee structures for 12 months, 45,225, and you can use my code and get the discount. Similarly, for 24 months, The fee structure is 66,600 and you can use my code and get the discount. Okay. Similarly, my dear friends, one more Unacademy is planning one more important combat. Okay. Unacademy combat, my dear friends. India's largest fortnight competition for the GATE. Okay. Access the GATE preparation within 65 minutes. Challenging questions has been curated by the best educators. My dear friends, okay, take it live and compete with the best. And this combat is January 12th, 2021 at 6 p.m. My dear students, okay, eligible branches mechanical, civil, electrical, ECE and CSIT, all these particular branches, my dear students, okay. Similarly, those who are going to get the rank 1 in this combat, 3 months GATE and engineering services subscription, rank 2 and 3, 1 month GATE and engineering services subscription, rank 4 200, 500 rupees Amazon vouchers, my dear students, okay. And unlock using my code, my dear students, as you know that code. That one is BNR10. Using this code, you can conquer it, my dear students. Okay, similarly, biggest ever surprise. Okay, for the South English people, my dear friends. Okay, already it has given on the New Year gift. That is South Indian English channel has started and it is running successfully, my dear students. Okay, similarly, plus batches taken by the inside faculties. Inside the subscription, my dear friends, for the departments of EC and electrical. Okay, target engineering services films 2021 batch D, rank booster batch for GATE 2021 batch D, and target engineering services films 2021 batch C, and rank booster batch for GATE 2021 batch B, my dear students. Okay, these are all the batches, okay, that are running successfully. Some batches has been started in the month of November and some batches has been started in the month of okay, December, my dear friends. Okay, there are certain other batches that has been started, that is Ascent for GATE 2023. English and Hindi starts on the 21st of the December, my dear friends, the last week of the last year, by the topmost educators. For electrical, Ascent for GATE 2023. This is for Ascent ECE. This is for Ascent electrical, which will be taught in English and Hindi, my dear friends. Okay. Similarly, Evolve for the GATE 2022 electrical batch A, which will be taught in English and Hindi, my dear students. Okay. Similarly, my dear students, Evolve for the GATE 2022 ECE batch A, which will be taught in English and Hindi, my dear students. Okay, very, very important parameters. Okay, similarly, Unacademy GATE English channel schedule for the month of January. Communications 9 a.m. to 10 a.m. Engineering Mathematics 10 a.m. to 11 a.m. Analog Electronics 4 p.m. to 5 p.m. Maths 5 p.m. to 6 p.m. and Aptitude 6:15 to 7:15. Measurements 7:30 to 8:30 and Electrical Machines 8:30 to 9:30. My dear students, okay. Similarly, these are all the important parameters. Just I am going to bring it to your notice over here. So already I told you, my dear students, we have started the noise topic in the last class. Okay, my dear students. Okay. Good morning Revati. Good morning Monica. Good morning Kanakai sir. Everyone, noise analysis we have started, my dear friends. We have finished in the previous class regarding the types of noises and the previous year questions on this internal noise, my dear students. Okay, we have finished all these particular parameters. Okay, the transmission of white noise through an LTA system, transmission of white noise through an, okay, through band pass filter, through low pass filter, we have finished, my dear friends, and the problems also, my dear friends, we have finished in the previous session. Now in this session we are going to some more problems, my dear students, okay, on this noise. Now, my dear students, in this session, an amplifier operating over a frequency range of 18 to 20 megahertz, my dear friends, has a 20 kilo ohm input resistor. Okay, what is the RMS noise voltage at the input of this particular amplifier if the ambient temperature is 27 degrees? If the ambient temperature is how much, my dear students? 27 degrees centigrade. Degree centigrade, my dear students. Okay, he has given the amplifier bandwidth, the frequency. C has given the frequency, my dear students, which can be written as B also, which is in the range of 18 to 20. The difference is the bandwidth, my dear students. Okay, amplifier bandwidth, which is equal to 20 minus 18. How much? How much, my dear students? 2 megahertz. 2 megahertz, my dear students. Okay, and the resistance you only given 20 kilo ohms. Okay, now he is asking the noise voltage, my dear students. Okay, I told you the formula itself is temperature he has given is convert in Kelvin. (300 degrees Kelvin, my dear students. Okay, 300 degrees Kelvin. Then noise voltage, which is equal to, I told you the formula, my dear students. Okay, 4 kT, my dear students. I told you the formula. Okay, 4 kT into B into R. I told you this particular formula. From this, Vn equal to under square root of this is, my dear students. Okay, now substitute the parameters. Substitute the parameters, my dear students. What are the parameters he has given substituted? This is K, my dear students. Okay, K is over next T, 300 kelvins, my dear students. Okay, then B, bandwidth is 2 megahertz, 10 power 6. Okay, 2 into 10 power 6. Okay, into very limited resistance, 10 kilo ohms. How much? How much noise voltage you are getting, my dear students? How much you are getting, Monica? How much you are getting? Okay, very good. So tell me. Vn. How much? Anybody? The answer itself is 18.2 18.2, my dear students. Okay, microvolts. Like that you are getting, my dear students. Okay, similarly, one more problem. An amplifier operating over the frequency range of 445 to 460 kilohertz has 200 kilo ohms input resistance. What is RMS noise voltage at the input of this amplifier if the ambient temperature is 17 per degree centigrade? Per degree centigrade, my dear students. Okay, then here bandwidth can be written as del F also 460 minus 445. How much you are getting? This is 15 kilohertz. Okay, input resistance are equal to how much, my dear students? 200 kilo ohms. 200 kilo ohms, my dear students. Temperature 17 plus 273. You are getting 290 degree Kelvin, my dear students. Okay, now noise voltage. This is the formula. Okay, similarly, you are getting, my dear students, the value itself is 4 into K value, my dear students, into temperature 290 into resistance my dear students into bandwidth. How much you are getting, my dear students? How much you are getting? This value is how much? You are getting, this is 69.3 microvolts. Like that. You are getting, my dear students. Okay, over here. Okay, very, very important one. Is that clear? Okay. Now I am going for the next concept. Very, very important concept, my dear students, in noise. That is two-port networks in cascade. Okay, see here, two-port networks in cascade is very, very important, my dear students. Okay, before going for the problem, two-port networks in cascade. Very, very important topic. Listen carefully, my dear students. Two-port networks in cascade. I am cascading the various networks. Cascading means one after other. This is a receiver. two port networks. All these things are, my dear students. Okay. Okay, my dear students. Okay, these are all the two port networks over here. Okay, very important over here, my dear students. Listen carefully. I am going to bring back the various formulas here. Various formulas, my dear students. See here, this is G1 and this is G2. This is gain G3, my dear students. Okay, and for this one, noise figure is F1, F2, F3, my dear students. Okay, and the equivalent temperature, this is T1, T2, T3, my dear students. Okay, these are all the equivalent temperatures, my dear students. Okay, now I want to bring back, means one network is cascaded with the other one. Okay, now what is noise figure? Generally the formula for the noise figure is what, my dear students? The noise figure equal to input signal to noise ratio by output signal to noise ratio. That is general formula. Okay, but here the two port networks we are correcting here. Okay, what is the, these are all the noise figures of each network. Now what is the overall noise figure? What is the overall noise figure, my dear students? Overall noise figure equal to F equal to F1 plus F2 minus 1 by G1 plus F3 minus 1 by G1 G2. Okay, like that. This is the overall formula. Like that it is going on, my dear friends. Like that it is going on. Similarly, overall equivalent temperature. Overall equivalent temperature T. T equal to T1 plus T2 by G1 plus T3 by G1 G2. Like that it is going on, my dear friends. Like that it is going on. Is that clear up to here, everyone? Okay. It is going on like this. Okay. Then there is one more formula that comes into the picture, my dear friends. Okay. And that particular formula is like this. There is a relationship between the noise figure and that is overall temperature and that is equivalent temperature. Noise figure F, which is equal to 1 plus T by T naught. T is the equivalent temperature. This is overall temperature or ambient temperature. Okay. If you want to this one, what is the formula for T? Means T by T naught equal to F minus 1. Then T equal to F minus 1 into T naught. This is another formula. All these formulas we are going to use in solving the problems. Okay. Similarly, now do the problem, my dear friends. Find the overall noise figure of the four stages of the amplifier cascaded with. Cascaded with, my dear friends. F1 equal to 10. Okay, G1 equal to 50. Okay, F2 equal to 5. Okay, G2 equal to 20. My dear students, and F3 equal to 8 and G3 equal to 10. Okay, and F4 equal to 12. My dear students, and G4, okay, equal to 15. Overall noise figure means F is asking. Okay, what is this F? F is equal to F1 plus F2 minus 1 by, okay, up to G1, up to where it is there, F4 is there. Okay, next F3 minus 1 by G1 and G2 plus F4 minus 1 by G1, G2, G3, like that. Okay, we have to represent in this one, my dear students. Okay, then it will be F is equal to, what is F1? 10 plus, my dear students, F2, which is equal to 5 minus 1. G1 is how much? 50. Okay, 50 plus F3 minus 1, 7 divided by G1 into G2, 50 into this. Okay, G2 is how much, my dear students? 20. Okay, so how much you are getting? 1000 plus F4, 12 minus 1, 11 divided by G1, G2 multiplied by G3. How much it is? Again, how much it is, my dear students? Okay, so you are getting this value. Okay, is G3, G1, G2 and G3, my dear students. Okay, very very important. You need to represent like this. Okay, G1 T3, no, F2 F3 minus 1. Okay, right, F4 minus 1, 11 by G2 is, this is 1000 and G3 is how much? G3 is 10. So how much, my dear students, you are getting here? You are getting what is the value here, my dear students? Please respond over here. Simply watching. $52 jar here. This is 1000, 10,000. Then you are getting how much, my dear friends? You are getting the value is 10.0881. 10.0881, my dear students. Okay, you are going to get such a parameters over here, my dear students. Okay, is that clear up to here, everyone? Okay, next problem. Next problem, my dear students, very very important problem. This particular problem also, he has given the question in an amplifier. In an amplifier, the first stage is cascade of 5 stages. 5 stages cascaded has, my dear students, he has given the value equivalent temperature T1, which is equal to 75 degree Kelvin, my dear students, and G1 equal to 0.5. He only given, my dear students. Okay, G1 equal to 0.5 and each succeeding stage has, this is very very important point, each succeeding stage has effective input noise temperature and available power gain 1.75 times of the stage preceding to it. What is the cascaded effective input noise temperature? Very good question, my dear students. Okay, he has given like this the stages, different stages, my dear students. How many stages are there? 5 stages. It is a 5 stages. Draw 5 blocks. Draw 5 blocks, my dear students. Listen carefully. He has given T1. -75 degree Kelvin. He only given and gain for this one. How much, my dear students? 0.5. Gain equal to 0.5. Okay. Now he has given that each gain, my dear students, that is multiplied by the each stage multiplied by 1.75 times. 1.75 times, my dear students. Okay. T1 and this one. Okay. Then here it is T2, G2 and T3, G3, T4, G4, T5, G5, my dear friends. Okay, and T2, C has given that T2 multiplied by 1.5 times, 1.75, sorry, into previous one, 75. And gain is also G2, my dear friends, which is equal to 1.7 to 0.5, like that. Okay, previous stage. So what kind of values you are getting here? 131.25. Here you are getting is 0.875. 0.875, my dear students. Okay, and T2. See here T3 also like that. Okay, when you are multiplying this value multiplied by 1.75 for this one, then what you are getting here? T3 is this value multiplied by again 1.75. Okay, which you are getting is 229.68 degrees. This is, my dear students. Okay, 68 degrees, and G3 you are getting is 1.531, my dear students. Okay, T4, this you are getting the next time itself is 401.9, and a G4 parameter, very important, that is 2.679, and a TE5 702.6, 702.62, 702, yes, and this is G5 4.68, 4.68, my dear friends. Okay, like that. Now substitute all these things, my dear students, in the formula what I represented. He is asking that not overall noise figure. This time he is asking effective noise temperature. Okay. Effective noise temperature T equal to TE1 plus TE2 by G1 plus TE3 by G1 G2 plus TE4 by G1 G2 and G3, my dear students. G3. Okay, like that we are representing. Okay, how many cascaded? Up to 5 stages is there. Okay, then it will be T5 divided by G1 G2 G3 and G4. See here, up to 5 stages are there, my dear students. Okay, then it will be first one is 75, my dear students, and TE2 equal to and a G1 value. Okay, what is the value of the G1? The G1 is the gain of the previous one. Gain is the previous one gain, my dear students. Okay, this becomes the gain, this value. Okay, the gain. Okay, this becomes the gain for this one. Okay, this is giving the input to over here. So here we need to represent plus 0.875 plus 229.68 divided by plus, my dear students, 401.9 divided by plus divided by see the question here. Available power gain are each 1.75 times of the stage preceding it. Means this gain becomes this one. Okay, multiplied by this particular parameter. Okay, you got it? I have done this one, my dear students. Then it will be TU you are getting is 550.26 degree Kelvin. 550.26 degree Kelvin, my dear students. Okay, like that you are getting the answers over here, my dear students. Okay, very very important one. Okay, similarly like that we need to do over here, my dear students. Okay, next problem. The noise figure of the op amp is 0.2 decibels. Find the equivalent temperature. Find the equivalent temperature, my dear friends. Okay. Then T equal to T naught into, my dear friends, F minus 1. Okay. And always the T naught, the overall temperature, always it is a constant, my dear friends. And that particular T naught equal to 290 degree Kelvin. Always this is constant. This particular parameter. Okay. Then it will be, okay. Then it will be, my dear friends. So we need to use the parameters first. We have to find out the F value because F is not there. The noise figure has given in decibels. Okay. F equal to 0.2 decibels, my dear students. Okay. He has given this one. Okay. Convert here, my dear students. Okay. Then it is equal to 10 log. Okay. My dear students, of F equal to 0.2. Then you are getting the F values how much? First, bring it into linear values. 1.047. My dear students, bring it into the linear value. Okay. Similarly, then you are getting T, F equal to this value. Then T equal to 290, my dear students, into 1.047 minus 1, where you are getting the value itself is 13 points, that is 13.6, my dear students. Okay. You are getting this particular value over here, my dear students. Okay. Similarly, is it clear, my dear students, up to here, everyone? How have I done the problem over here? Please respond over here, my dear students. Is that clear up to here, everyone? Okay. One more question. Another question. See here, the noise figure of an amplifier. Of an amplifier at room temperature. My dear students, room temperature means always this 290 constant. T naught value, okay, is 0.2 decibels. My dear students, okay. Now this, okay, the parameter itself, okay. Now he has used this particular value over here, my dear students. Okay, very very important. Now he has given the parameters in such a way. Okay, now here he has given the parameters, the amplifier with a gain. See here, not this one, the amplifier with a gain. Sorry, this is the question. Already we have done the problem. Another question. This is an amplifier, my dear students, with a gain GA equal to 40 decibels. This is a question. And bandwidth, my dear students, 20 kilohertz. Okay, is found. Is found, my dear students. See here. Okay, he has given, my dear students, available output noise power. This is available output noise power. This is also given. Okay, 10. Okay, he only given, my dear students, all these particular parameters. 10K into T naught. when Ti equal to T naught, my dear friends, find equivalent temperature and noise figure. Noise figure, my dear friends. Okay, the formula for the overall T is equal to Te plus T naught. Te plus T naught, my dear friends. Okay, bring back Te outside, which is equal to T minus T naught, which is equal to T minus T naught. Okay, but here one more important parameter. He has given that this temperature T equal to, he has given is 290 here. Okay, and he has given the T naught, he has changed, given here, which is equal to 10 degree. Then T equal to, my dear students, 280 degree Kelvin. Okay, then what is the formula? F is equal to 1 plus, this is also formula, 1 plus Te by T naught, my dear students. Okay, then it will be 1 plus Te is how much? 280. Okay, divided by T naught is how much? T naught is how much, my dear students? T naught equal to, as usual, here 10 is there. Then it will be how much? 29, my dear students. And to confuse you, he has given all this data, and all those things. Okay, so but the main problem itself is that we have seen the relation. This relation I told you, and this formula I forgot to tell. This is equivalent temperature plus overall temperature, and this is total temperature. Okay, he has given that this time this Te itself is that we need to find out. Okay, the total temperature is 290, and he has given this particular temperature minus. Okay, so we need to do this one. Okay, T minus T naught. Okay, this time he has changed this one. This is T naught. Is that clear, my dear friends? How I done over here? Okay, to confuse you, generally the T naught should be, always we are going to take it 290 only, but he has changed certain parameters here. Okay, 290 means if it is becoming 290, this is means he has changed certain parameters. As usually, this is the value we have to take for other problems by default. For in this question, he has taken the total temperature is 290, and here the T naught equal to 10, then automatically equivalent temperature becomes 280. Then the noise figure, my dear students. Okay, how to calculate all these things, my dear students. Okay, with that we have completed this particular noise over here. In tomorrow's class, we are going to study about the first topic, that is noise analysis, my dear students, in the digital communication systems, my dear students. Okay, we are going to study that particular concept over here. Okay, hope that you have enjoyed today's session. Any doubts, you can keep your doubts, my dear students. Okay, in the doubts group. Okay, similarly, the number of followers in the Facebook is day by day increasing as far as Unacademy is concerned. Okay, Unacademy English channel, not Telugu channel. It is become the English channel, my dear friends. Okay, where you are going to access the different subjects in different languages. India's #1 other channels also there for different competitive level examinations. You can access the different subjects, my dear friends, in different channels. Finally, thank you, my dear friends.